Welcome back, friends, for part 3 of exponential functions. So just to do a real quick recap before we go on, right, we were talking about just our basic format of an exponential function typically looks like this, right? And in the last video, we talked about how your a value is your y-intercept, and your b value is your rate. Now, I can't remember, I don't think I said it in the video, but I know in class that I said that there's a little disclaimer here about that being your y-intercept. And we're going to take a look at that today. And also how we kind of go about looking at these functions. And as you take a look at functions 1 through 5 here, you should notice is like take a look at which ones are a little bit different than the others. And I'm hoping that you can see here, look at function 2 and function 3. And if we think about those ideas of the transformations that we talked about in the first video, right, we can see that this whole function is being shifted up 1, and in function 3, it's being shifted down 3 spaces. And so we're going to take a look at how does that impact our table values, and how does that maybe impact identifying our key features just from the equation itself, and maybe even just from the graph. So what you want to do is you want to go ahead, and if you haven't already done so, you can use your graphing calculator and input all of these functions and get all of your table values. But I want you to go ahead and go through, get all your table values, go ahead and graph them, and we want to go ahead and identify what's is it a growth or a decay? What was the y-intercept, the rate, and so on. All right, when it's talking about is there a reflection, right, more specifically, I'm talking about is there a vertical reflection? So I want to make sure that that part's clear. Is there a vertical reflection? If there's not a vertical reflection, you can simply write NA or none, okay? And then remember your domain is your x values, so you're going to go from left to right, so the least to the greatest. And your range is your y values. So you're going to go from the lowest to the highest, right? We always go least to greatest when we're listing those out. And that's going to be our interval notation. All right? So again, if we were to kind of just take a look at these based off of what we know about transformations by looking at the equation, right? The only one, and I think there's 5. Hold on, let me scroll out a little bit further, okay? Notice I can already make a prediction. These two are going to have a vertical reflection, right? Because of that negative that's out in front and what I understand about transformation rules. All right, so go ahead and pause the video, and when you're ready, come on back. All right, friends, welcome back. And so here, I wanted to just give you a quick glimpse. You can pause the video at any time to or take screenshots to kind of get that information in. But I wanted to take a look mostly at function 2 and function 3. Right now, if I give you the equation, it's very easy to plug in the values and get out the numbers and create the graph, right? And maybe even go ahead and identify all of these key features just from the equation itself. But the idea is that we want to kind of see how does everything connect. What if I didn't give you the function rule and I only gave you the table, right? Could you still identify all of the key features? And so that's what we really want to take a look at today, all right? So if we're taking a look at this stuff here, right? Imagine that I had not given you this function rule. Well, remember what we talked about, how there's that a value and there's the b value in that general setup. And I had a disclaimer here about this a value. I said, well, it's usually the y-intercept, okay? But I want to take a look, and we can star function 2 and function 3. So if we go take a look, let's highlight the y-intercept here. Oops, wrong. That's not y-intercept is, let's get a little more precise, Ms. Pariseau. There, it's when x is 0. Okay? And so if we take a look at our y-intercept values, right, in all of them except function 2 and function 3, we can actually see the y-intercept, okay, is that very first term. It's the a value. But notice in function 2 and function 3, it's not. But let's take a look at that a value. Notice here, the a value is 3. But how does it compare to what the actual y-intercept is? 3 plus 1 is 4. Right? Same thing here. What is actually the a value in function 3? It's actually a 1. And what's 1 minus 3? It's the -2. So my little disclaimer here is that when you have this format, if there's, right, kind of, let's just make it a D for right now. Notice in all the other graphs what the asymptote is as well, right? Look at function 1, function 4, and function 5. In function 1, 4, and 5, the asymptote is always 0. And if you think about that, that's because there's nothing being added or subtracted to those functions. If you look up top, I'm not sure if you can see my cursor. I'm kind of moving it back and forth up there. Okay? But there's no vertical shift happening. However, in function 2 and function 3, there is a vertical shift. And that actually impacted, if we go down to our key features here, that impacted where our asymptote is. And so essentially, that tail of the exponential equation, or function, sorry, right? This tail actually lets us know about the vertical shift, but it's also going to shift our y-intercept. So while, yes, A is our y-intercept, if we go up or down any, right, that means that our y-intercept is going to go up or down that much. So essentially, our y-intercept is really whatever the a value is plus the d value. That's another way to look at it. Now, the other part I want to tell you is, okay, let's say I didn't give you function 2 or function 3. I didn't give you the rule. In function 1, 4, and 5, we could identify some of these key pieces. I can identify the y-intercept, which is my a value, right? There's my a value. And my b value is the pattern, right? How did I get from one to the other? Well, here I'm multiplying by 4. Here I'm multiplying by 4. I'm multiplying by 4. And if you're not sure how to figure that out, you're like, well, how did you know it was multiplying by 4? Because I know it was not adding, right? And I might, this is actually, that should not be a -2. That should be a, no, that's right. Oop. Back up. I did this last time too. Notice I went from 0.5. I need to go from -1 to 0, from here to here. I want to count by ones. I was counting by halves. All right? So this number times 4 gives me a half. This number times 4 gives me -2. Okay? And if, again, notice this table was a little bit different. My table change was not counting by ones here. Okay? But for every one that increases here, this is dividing by 4, aka multiplying by 1/4. Okay? So we can see the rate in here. So if we can see the y-intercept and the rate, we can write our equation. We can write an exponential function. But where the problem comes in is when we have a vertical shift that happens. If you were to take a look and just kind of analyze these problems, like, okay, what did I do? Is 2.5 times 1/2, is that 1.75? No, it's not. And the reason that we're not able to see the rate change is because of this vertical shift, okay? So when there's a change, when there's a vertical shift that happens, it's harder to identify the rate from just looking at the graph or from looking at the table values. Everything else, we can simply say, hey, 0.5, for example, times what gives me 1.5. You basically are just taking the next value and dividing it by its previous value to get the rate, okay? So again, you're asking yourself, 0.5 times what gives me the next value? 1.5 times what gives me 4.5. We're just asking, what am I constantly multiplying by? And we're not going to be able to recognize that very easily when we get to ones that have a vertical shift. And the reason that I point that out to you is just that I just want to let you know that we can't always identify it immediately from the table, okay? All right, so let's kind of go back now with this idea of like we've got this connection. Let's go take a look, and we're actually going to take a look, first off, if you haven't already done so, on on puzzle number 1, go down to the y-intercept, and you need to change this to say 0, -3. I dropped a negative sign, okay? All right, so here's the thing. Here's what we want to do, all right? I want us to write a function rule for this, and I'm giving you certain pieces of information, and it's your job to really explore those pieces and say, what can I figure out? Well, at the end of the day, here's what you need. It's just like when we were doing slope-intercept form. You need the slope and you need the y-intercept. It's the same thing here. We need the y-intercept and we need to be able to identify the rate. Those are the two things we need in order to make an exponential function, okay? So we're going to go ahead and collect all of our data based on what's been given to us. So if I'm looking at puzzle 2, I'm going to go ahead and take a look. I see some clear points. I'm going to go ahead and highlight those. Those I'm kind of estimating on, so I'm just going to leave that. So I can see that when x is 0, my y value is 4. I'm going to go ahead and put that up in the table here. When x is 1, I have 2, and when x is 2, I have 1. Well, that's actually enough information to help me figure out what the pattern is. Like, how did I get from 4 to 2? I divided by 2, aka multiply by 1/2, right? And let's just see if that pattern continues. All right, so that means that if I multiply by 1/2 again, that when x is 3, I get 1/2. And that looks about right. Again, we can't go precisely because we're estimating. Well, I can now reverse that. I'm basically saying I took some number and took half of it to get 4. Well, half of what number is 4? 8. So from there, I have all the information I need. I have my y-intercept and I have my rate. So that is enough to build my function rule. So I know that the output q of x is equal to my y-intercept times my rate. We want to put it in parentheses to say this is what's getting raised to the x power. And now you can go ahead and plug this in, test it out in your calculator, plug in this function rule, and then hit your table settings and check, did you get these values? And now we can go from there and we can go ahead and see, and visually I can even see, okay, this is a decay. My y-intercept was 4. I've gone ahead and calculated that my rate is 1/2. I can see that my asymptote is y equals 0. Again, remember when we're talking about reflection, I'm saying was there a vertical reflection? And there was none. My domain, okay, it looks like it's stopping before -1, but remember, it keeps going in that direction, it keeps going in that direction. So it's actually going off into -infinity, and it's going off into +infinity. Now for my range, remember, here's my asymptote right there. So it never gets below that line. It's approaching that line. So it's actually approaching 0 is the lowest that it goes, okay? And then the highest that it goes is off into +infinity. So that's what you're trying to do here on these problems, is you're trying to make that connection. Like, okay, how can I identify with these clues what my y-intercept is and what my rate is, and how can I use that information to complete the puzzles, write a function, graph it, and perhaps even just identify some other key features. So good luck with that. And let me know if you've got any questions.